Okay, in our last video we talked about when a rational expression is defined. Our main idea in this chapter is we're going to be working doing arithmetic with these algebraic fractions. So first thing we do, just like with regular fractions, is you want to be able to simplify. So we're going to talk now about simplifying rational expressions. Key part to simplifying rational expressions is a result that's known as the fundamental principle of fractions. It's actually this principle that governed everything you ever did with regular fractions as far as simplifying them, multiplying them, dividing them, adding, subtracting, building common denominators. This fundamental principle was kind of the basis around how each of those things worked. And it says very simply that if you have a common factor being multiplied at the top, in the numerator of each fraction, then you can cancel that common factor out. If you flip it around the other way, as long as you multiply both top and bottom by the same thing, you have an equivalent form of that fraction, and this is what we often do when we're getting our common denominator. Okay, so that's known as the fundamental principle. It tells us we can cancel out a common factor. Let's consider a numerical example. Consider the fraction 25 over 35. Right? What we can do is we can take that 25 and rewrite it as 5 times 5. Right? And take that 35 and rewrite it as 7 times 5. Right? And then we recognize that, hey, there's a 5 that's common in both of those that can be canceled out. And so we get the answer of 5/7. Now that's going directly with the fundamental principle. How it worked in practice, what we usually do, right, is we would write our 25 and our 35, and we said, well, let's divide a 5 out of both. That's what we typically do in practice. But really this is what's going on, even though we don't necessarily write it out that way. Although we're going to find it's helpful when we're doing these problems with the algebraic fractions to kind of write it out so that we can see those factors alongside each other. Okay, so let's consider an example. Consider this algebraic fraction, 3x squared plus 12x over x squared plus 4x. You may be tempted to say, oh, I get to cancel the x squareds there. All right, I got an x squared in both. Let me cancel them out. See, we can't do that because those x squareds are actually being added together to something else. Right? They're not factors. They're not a part of the product of the whole numerator. And so you cannot cancel them out. Same thing with the 4x and the 12. You may say, oh, I get to cancel those things out. No, we can't. But what we can do is look at that numerator and look at that denominator and factor it. By factoring it, we rewrite it as a multiplication problem. And then if there's anything common being multiplied in the top and bottom, by our fundamental principle, we can cancel those out. So I'd ask you to pause the video, take a moment, and factor both the numerator and denominator. And so we're going to find ourselves doing this a lot throughout the remainder of this chapter. So in the numerator, we say, well, I can take a 3 out of both, and oh, I can also take an x out of both. So I factor out a common factor, and that's really all I can do. And don't forget about that common factor factoring. That's something you always want to look for. In the bottom, I recognize that I have an x squared and a 4x, so I can pull an x out of both. And now if you look at the numerator and denominator, each of those pieces is being multiplied. So when you have common things, like the x's, we can cancel those out. And like those quantities, x plus 4, we can cancel those out. And so it turns out this algebraic fraction is actually the same as 3 over 1, which would simplify to be just 3. Okay. So that's the process of simplifying, and we'll look at some more examples in further videos. Until then.